Hello, everyone. Welcome to today's developer coaching webinar. My name is Tara Van Cleve, and I'm part of the database organization here at Oracle. Today, we're excited to dive into Oracle's AI building blocks for the FinTech space and to show you how to put real-world AI into production code. If you have any questions, we have enabled the Q&A section of the Zoom and we'll be answering throughout the hour, as well as leave some time at the end for any remaining open questions. Today's webinar will be presented by Paul Parkinson, Architect and Developer Advocate, and Herman Viscuso, Director of Developer Community. So without further ado, I will hand it over to Paul to take it away.
So my name is Paul Parkinson. Just super quick, I've been at Oracle 24 years. I've been developing like 40 some years now. So I was in core development at Oracle for 20 some years, in the last 3 or 4 years as a developer advocate. So super psyched to present this to all of you. I'll let Herman, he has a similar background, so I'll let him introduce himself. But super psyched to present all of this to you. There's a lot of content here. So I will ramble, but I'll try not to, and I'll give you high level, but also developer details. And that's the idea here is developer oriented, but the use case being in the financial space. Um, so let me get right into it. So what I do here is I actually, instead of doing a PowerPoint with demos, we do a demo or application, and the content is in the actual application as far as the material, context, etc. And so just real quick about this app. Um, again, at the workshop's named microservices, but this can be run, any one of these topics we're going through can be run by itself. So none of them are dependent on the other. And they can be run in Kubernetes, but they can be run standalone as well. So I don't want to make it seem like you have to go into Kubernetes to run any of these, okay? And then each of these pages is broken down with three bits of information to start off. The first is the financial process, such as publishing financial APIs. The second is the tech that we're showing to provide that financial process. And then the third line is an actual Oracle customer that's using this, right? So this is relevant material. And these are customers that are using this technology for this business process. And so obviously it's not it's a simplified, as much as possible, simplified representation. So, for example, Amex is indeed using this technology as far as globally distributed database for their credit card purchases. But obviously I don't have the full Amex implementation, but it's the exact same use case. Okay. So to keep it relevant, and this is, for FinTech development. And then each of these pages has a walkthrough video, developer notes, and different differentiators to not just to show Oracle's best, but to also give you the idea of this is what Redis does, this is what TrueCache does, things like that. And then the direct links to the source code and the workshop. So all of the source code is here, and this is the QR code you saw, and you'll see again at the end. Um, all of the source code is in this repo. So we have a few different verticals going on in this repo. This is financial. And then the corresponding workshop. So they're linked from each of these pages directly to the relevant bits, right? And then in the page itself, we actually have code snippets. So not to go crazy into the code, but just to give you, real quick relevant snippet, so for example, you see the messaging code over here. These are the 5 or 6 key lines. Okay. So I just wanted to give you a kind of the setup of the application as we're walking through each of these. So the first thing I'm going to talk about is the overall architecture. And again, I'll repeat, you don't need to use Kubernetes. We're just using, that's 70% of new development, from Gartner and Forrester, they all give the same readings. 70% of new development is cloud native, and 70 to 80% of that is Kubernetes based. So that's why I have all the YAMLs and everything in the workshop for you to use if you want to use Kubernetes. But this is the architecture as far as the components we cover. Again, these are the developer sections with the video that I mentioned. Um, this is the entity diagram. Now, one thing you're going to see as we go through this, and one of the big things that's awesome about the Oracle database is the fact that it's multi-purpose, or what we sometimes call converged, not because it's a monolith, but because it's converged as far as the multi-purpose asset aspect, and the fact that everything can be transactionally done. So, and pick any of these technologies. It's in the same database, yet it has that microservice scaling capability because of the breaking it down by PDB or whatever you want to do. But you have this separation at the same time. So what we have here is, as I said, each one of these tasks, these labs here, can be run individually, but they all share an accounts table. So you can see that converged aspect of how they work together. And you can bolt in however many you want, that type of thing. I like to just bring up, if you're completely new to Oracle, just clicking through, sign up for an OCI account, and get a database. It's completely free, or get the container. That's completely free too, and run it locally. And then go into the console, and it's actually a little bit hidden in my opinion. Under this database actions, click view all database actions, and you'll see what I mean about how much functionality is, that little drop down tab there, how much functionality is in the database, and just kind of click around if you want to see what's there. One of the pages, so that's kind of like functionality. And then if you go into the data transforms, you'll see that you can, just connect any data source. So it's like an amazing hub, especially with all our multi-cloud stuff. Amazing hub for whatever information you're using. And, as we'll talk about vector database, you'll see how that's really optimized. You don't have to ship things around. You can vectorize in the database transactionally, things like that. So I'm just saying, click around the click around the console. It's pretty eye-opening, all the functionality for a developer. And so then I just wanted to touch on the topic of observability because even if you're not using microservices again, but especially if you are, that observability is actually, absolutely critical. And so we have a very robust story around observability that we've been working on for, like 8 years now. And so we have very quickly, the metrics, logs, and tracing, the three big ones, and eventing, some people will say, as far as observability. We have exporters for all of these. And one key one, and when you do this exporting, you can use SQL. So that's very nice because you can get very precise. You can say, I want these rows from my alert log. Not like a kind of an elastic thing where you're just dumping everything in. You could be very specific. So that's nice. But my favorite feature is actually the tracing feature because we have something that just no other database has. And that's the ability to actually trace into the database. So if you're working with any other database, you'll see that, you have your trace, tracing all the way through from your, whatever it is, your cell phone or your web app through Kubernetes or whatever the mid tier is. And then when it comes to your database, it's just the node stops there. You grab your IDs and then you go in the database and continue. So what we've implemented is an actual trace exporter in the database. So what you do, what happens is all of our drivers will propagate the OpenTelemetry tracing ID from the application into the database. Then the client and the database are putting traces to the collector, and then they're of course combined on the collector side naturally. That's part of any tracing collector, and you can finally see the end to end from all the way down the tiers. And I always have to bring up the joke because it's a classic. When you're working, it was always the developer. Customer says things are going slow. The app developer says, "Oh, it's the database." The database says, "Oh, no, it's not the database." And then they both agree to blame the network, right? Because the network is this nebulous thing. So what's pretty awesome, with this tracing, as you can see here, it's a pretty crude diagram, but you get the idea. This is the application activity. This is the call over, and then this is the database trace activity. So we can see that it was indeed the network's fault. So anyway, that's kind of something you cannot do with other databases. It usually stops right here. So super powerful. And so then when you put it into whatever you're using for observability, this is open telemetry. So whatever cloud you're using, whatever open source like Grafana we see here, it's going to work. And you're going to be able to trace metrics, logs, and tracing end to end. So I spent a little time on that, but it's because it's very powerful, especially for DevOps, which is what you guys are. So with that, I'm going to hand it over to Herman for the first topic, which is ORDs and Open API.
Okay, thank you, Paul. Okay, so yeah, this is the first part. It's called basically published financial APIs project inside the lab. I just want to say that this lab is great because it's basically providing all of the guidance. For example, when you just click here in developer resources, you get the full walkthrough of the section plus explanations, etc. So it is great. You have all the source code, you have a walkthrough, etc. So there's no excuse not to try it out. So you can go ahead basically and try. So the this is the we call it the Published Financial APIs project, and it's using Oracle REST and Open API. So REST is a technology that we use within the Oracle database to basically expose REST-enabled API endpoints. And this example is very simple. It shows you how you can REST enable any objects or processes in the database, in this case related to accounts. This tends to be popular in the financial industry for publishing APIs. And as you can see, you just need to use SQL. As you can see here, you're basically using SQL, and you are basically REST enabling a table, for example. I think that we have a lot of demos. You can search for ORDS, autonomous database, for example, webinars or tutorials, and we show you how to basically expose data from the database and make them REST enable. But we also show you how to deal with authentication, for example, and a lot of other things. It's not just opening up a table to the world, but basically it is about creating a full-fledged REST system. Also use it internally. For example, to give you an idea, and I'm going to cover this in one of the other sections, we have a MongoDB API. Basically, you can use the Oracle database as if it were MongoDB, right? So it's using the same wire protocol. And if you take a look at the API endpoints, they are all look like this. So basically, they are also using ORDs. So once you enable, these tables, for example, in this case, we are enabling the accounts table, you get automatically URLs like this ones. Okay, for example, you get a URL to do a get on the accounts. You get a URL to do a post, for example, like here. And this is an example of what the content would be for that post. So we can actually this is basically using the same call that you see here to basically show you what we have in the accounts table right now. So this is live, okay? So as you can see, we have several account IDs, account balance, account names, etc. And this is important because we're going to come back to these accounts for the other example. So basically, account ID, there's a balance. So you can think of it as money, right? And then you have customer ID, customer name, etc., etc. Okay. So this is basically it for published financial APIs. So remember, you can always come back to this very simple example, but ORDS is more powerful. There's much more that you can do with ORDS. So please do a search on ORDS autonomous database tutorial, and you can basically find out all the more advanced features. But we have so many things to cover today that we cannot go deeper. Okay, but this is easily an hour of ORDS, basically ORDS magic. Okay, so let's move to the next topic, and please send your questions to the Q&A. All right. So we have the create and view accounts section of the lab, right? So this is showing how to create and view the accounts. Obviously, we are using MongoDB, and in this case, we're using the MERN stack with JSON duality. Okay, I'm not sure if you heard about JSON relational duality. It was a big thing when we were talking about the launch of 23AI, etc. So it is using transparently using the database as a relational data store and as a document data store without even the blink of an eye. Okay, so as we see in the as we have seen already in the architecture, we have a React front end, and in this case we have as I said, the MERN stack. So that's React, Express, Node, and MongoDB. Okay, and what we show here is the fact that you can access the Oracle database using the MongoDB API. So what we're doing here is we're simply creating and querying accounts. And we specify if we want to use SQL or Mongo to do that against the autonomous database. So for example, I can change here to SQL or Mongo. And you can see how the code changes here, right? So write data using, read data using. This is the SQL version. This is the MongoDB version. And here you have the same thing with read the data, okay? So for example, we could go ahead and choose Mongo, and we can do account ID, I don't know, 1200. We choose checking, savings. Let's choose checking, customer name. Let's just put my name. Okay, and I'm going to hit here on create account. Account created successfully. And now let's see if I can locate it. There you go. This is the one that I just created, right? 1200, my name, timestamp, etc., etc. So very easy. You can transparently switch between Mongo and SQL. Okay. All right. So let me see what else. Let me check. So I just want to tell you about the basic advantage of JSON relational duality. So as you can see, this is transparent. And the good thing about this is that thanks to JSON relational duality, if you have developers that have MongoDB skills or MongoDB expertise, those skills will transfer. And what I'm saying here is that you can also use the same tools that you're using with MongoDB, like Mongoose and those kinds of tools. You can use the same because we are providing a wire protocol level implementation here for the MongoDB functionality. Okay, so this is it for this part. Let's move to the let's move to the Polyglot. I call this like a Polyglot account update. So basically what we want to show here is that there are so many options, so many languages that you can use to basically create an account. And I just wanted to show you some of the differences here. Okay, like for example, we have Java, we have JavaScript, we have Python, etc., etc. Okay, so we are doing an insert here into the database, and we are updating account values. Okay, in this case, balance. So we are basically touching the balance. We are using several languages, and you can basically click on the code snippets and take a closer look. But one very important thing here is that if you take a look, you will see that some languages require you to execute a transaction. So let me see if I remember which ones. Let me see. Okay, well, here we have a session commit, for example. Some languages require you to execute a transaction. Others require you to save a context or to execute a context. So that depends on the language. But this doesn't mean that the language that is basically handling implicit transactions and not giving you the chance to do transactions, it doesn't mean that the language is less powerful, because sometimes the languages are handling that implicitly. Okay, so depending, so the fact that where you need to make a decision and you need to say, hey, am I supposed to use Java? I am supposed to use Python, etc., etc. That also depends on something that has to do with the libraries that are available for the language and the drivers that are available if you want to use like a low level or mid-level driver. And one of the things that I wanted to share with you is one of my presentations that I did some time ago. A quick look. This is one presentation where I was basically saying, hey, you are a developer, you have multiple options, you have thin clients, thick clients, multiple drivers, etc. So as you can see, you probably heard about JDBC to connect to the database, right? So that's a thin client that's basically working without tapping into any mid layer. But you have languages that are basically using some mid layer, like the Oracle call interface, for example, which is a low level interface, or the Oracle database programming interface for C, right? This basically puts some restrictions on what you can do in the language, right? So for example, the languages that are dealing exclusively with Oracle call interface are more flexible. You're allowed to do more stuff and you can define more things, right? While the languages that are using the interface for C, for example, have a very strict API, right? So basically, you need to comply to specific way of coding. So here you can see that we have multiple language support. Some of them are supported by Oracle, like the ones that are in red. Some of them are open source. Some of them provided by different companies, etc., etc. So the possibilities are really, really good. Okay. All right, so let me see if I covered. Okay, that was number 3, and now I'm going back to you, Paul, to cover the next section.
So this next topic here is well, near and dear to my heart because I've worked with transactions. Has been my main background for like the last 30 years or so, and especially for finance, right? So this is transactions. Again, I'm going to talk about in the microservice space because that is such a popular cloud native paradigm. Um, but what this comes down to is the ability, in this case, as we see, transferring funds, the classic ACID properties. Atomically, you need to withdraw from one account, deposit in another, right? And so when it this so I'm talking about a product here, MicroTX, which covers a few different protocols. So I want to make it clear that MicroTX, and this is written by the Tuxedo guys. So this is, there are no slouches in this area. It does cover multiple protocols, as I say. It handles the classic XA two-phase commit protocols that are used by, every bank to do bank transfers. But it also handles protocols that are more tailored to microservices. So when we're talking about microservices, there are a number of things to talk about, of course, but one of the biggest, maybe even the biggest, is the fact that you're just simply introducing more network, right? You're breaking your process into multiple processes and they're communicating over the network in one, REST or messaging, whatever it may be. So when you introduce this network, you introduce both latency, potential latency, and potentially more disparate systems that you don't have as much control over. And so if that latency is acceptable and you have control over your environment, you can continue to, use the old transaction protocols to keep, multiple services in sync as far as data integrity. But if that network creeps in or you don't have control over the system, the distributed locks that are used in old systems will cause a problem. And you'll have the lock held in doubt issues and things like that. And so because of that, the Saga pattern and workflow engines have become popular or necessary in microservice architectures. So this is an area that is probably the most difficult for data-driven microservices. Data microservices in general are more difficult than stateless. But the problem we're talking about here, where you have multiple services that need data integrity, is very difficult. And that's why we focus so much time on this. Okay. And I'll explain a bit more on this. But what happens when you don't use distributed locks because of the network and, or whatever the system set up, is that you need to use local transactions. And so that's nice because you don't have the issue, but the big issue with using local transactions is that you need to write your own commit and rollback logic. And you need to keep track of the changes that were made during that transaction so that you do the rollback or compensate correctly. And that is a tremendous burden on the developer, especially if you have a system that you're moving over to microservices. Now you have to write all your compensation logic, right? And this is a famous, infamous condition. And the estimate given by everyone is an 80% increase in your technical debt, development, and QA, right? So that's bad. So you want the benefits of microservices and you might want long running transactions, et cetera, but you certainly don't want that 80%, right? So that's why we focus so much on it. And this solution, this is my favorite thing to talk about because it is really awesome and one of a kind. So the one thing we have is micro TX, which is coordinating the transaction, right? And this is just like old systems. You have two banks, two participants who want to be in the same transaction. Micro TX is taking care of that so that you hit commit and roll back, right? Now for that 80%, as far as the compensation logic, what we have is a new feature called lock-free reservations. And this actually is a feature that has a couple advantages, or a couple features to it. The one is just straight up performance and throughput for hotspot rows like inventory. So, inventory's a hotspot row because it's updated so frequently. What this feature does is it does locking or reservations, more specifically, at a field level. So again, and this is an ongoing theme with what we're talking about here is how it's powerful, but we focused on simplicity. So to enable this feature, you just put, you created a table before. Now on your numeric field, you just put the keyword reservable before it, and that's it. That's all it takes to enable this. And so what happens is just very quickly, I like to describe it by comparing and contrasting it with, existing locking models. So pessimistic locking, right? One transaction at a time, super safe, but slow. That's your select for update. Pessimistic locking, you have concurrency, but you're doing some bookkeeping as far as timestamps to keep track of when things changed. And old transactions lose, right? A transaction came in, grabbed inventory, did not commit. Another transaction comes in, grabs inventory. That old transaction comes to commit. It'll roll back because the inventory's not there, right? So with lock-free reservations, what's going on is we introduce a intermediary journal, which is automatically kept for you just by, like I say, putting that reservable keyword on your field. And that is it's an intermediary between the actual commit force to disk, and that is writing out the inventory changes and handing out promises or reservations, thus the word. And so those reservations or promises guarantee that that transaction, has been given that inventory, and no matter how long it runs, it's going to have it come commit time. So you have the single field that makes it fast, and then you have this intermediary log that makes sure that the old transactions don't lose. So that's awesome in the first place. And the analogy is kind of a perfect analogy is the shopping cart, right? Just literally the shopping cart. When you go shopping, you don't grab the whole row of cans off the shelf and put it in your cart. You grab the one can you need, and you put it in your cart, and no one can steal that cart. That's the way it's supposed to work. No one can steal that can from your cart before you get to the register. That's exactly what lock-free reservations are giving you. Okay, so that's the one feature. Coming back to these these microservice transactions and what are called sagas, these local transaction coordinated transactions. That journal that the lock-free reservations keeps is exactly the journal you would need to keep in order to properly do compensation logic. So that 80% of logic is handled by the lock-free journal that's being kept behind the scenes, and of course, all the logic in the feature that we have in the database. And so now that 80% becomes zero because you can go back and just do rollback and commit like you did with old systems, but you still get the atomic guarantees. So you can imagine how awesome that is, right? And this is again, like we showed before, this is in this app you can instigate crashes to exercise what I'm talking about. So the different crash logic here, you can see, and this is greatly simplified, what you would have to do if you were coding it yourself. Every step of the way, you need to maintain a journal that says, okay, now I enlisted. Now I'm going to commit. Here's what the value was before. Here's what happened if you try and compensate and then there's a failure. Then you're retrying compensations. It's just, real complicated. This is the difference when you use the lock-free reservation, and this is not an exaggeration. All you do is join your connection to this saga, this lock-free reservation, and then when it comes time to finish the transaction, you just do rollback or commit. So I hope I didn't spend too much time on that, but especially in the financial space, moving to microservices and so many bank customers we're talking to are making that journey into Kubernetes, right? This is the way. And like I say, MicroTX also supports the old. So when you're developing, you can flip a switch, say, okay, I'm still doing the old system. Now I switch over to the new system with this, this join and rollback. Is it still, is everything still working? And you can test it and everything. So I spend a little time on that, but that is really because no other database is close to having that. The guy that wrote this is Dieter Gaulick, and he wrote it in the 80s. He patented this in the 80s. So we've been, cooking this thing for decades. So let me move on. I get
Yeah.
excited, as you can tell with this stuff, with the transaction stuff. So moving on to the next topic. This has a combination of things, and this is the Amex case I was talking about, where they're using globally distributed database, so sharding is what that is, to manage their credit card purchases, right? And so, what's cool about that is the globally distributed database. Like I said, I don't want to go so much into this, but it fully supports Raft, which again is a transactional feature. That's why I'll end up talking about it a bit. But unlike so many other sharding products like Cockroach or something like that, you're getting this full Raft guarantee, and you can just write in SQL as you were before. So this speaks to the simplicity where you had your application before. Now you just use a globally distributed database. You get David's data sovereignty and all the sharding, scaling capabilities, etc. And all you had to do in your application was these lines of code, right? And it's really two lines of code. One is you're saying if you want your sharding automatically handled for you, all you do is set this property on the data source that says use sharding driver connection and you're done. So you took your app today, set this value, we take care of all the sharding and you're off to the races, as they say. Or you can manage your own sharding, which is like the example we see here. So you want to use your account ID or something like that for sharding, then you just create a shard and then, manually add that shard to your connection, and that's what you're using. So super simple and powerful is the theme again. The other aspect we're showing on this page is OML and spatial. So OML is Oracle machine learning that has been in the database for close to 30 years, way over 20 years. And this is, the old-fashioned models before all the LLMs and things like that. It's your data set and you train it. Super powerful. And, if you're whatever tools you're using, that's the other thing that's cool about Oracle being old and us being this multi-purpose database is that every technology that has come along, we are adaptable to it. So, whatever you're using, you name it, and it's going to work against the Oracle database. And so, for example, again, we have all these click-throughs to Jupyter and OML. If you're using Jupyter Notebook, this is included in the workshop, by the way. This is This is what I'm showing in the app. This is the back end of it, where you can, do things as far as, excuse me, as far as the transactions, the credit card purchases, etc., and then do this different analysis on it. But there's also, you can take your Jupyter notebooks or your Zeppelin notebook, whatever, and go into Oracle machine learning on the back end, and it has all of this functionality. So it has the entire ML ops lifecycle within this OML that I'm talking about, right? Everything from reporting to auto ML, all the management. So you can use this. It works well with any data science platform you're working with, whatever the cloud, whatever the Vertex or whatever you're using. But you can also just run the whole thing. And people, everyone loves this when they come to it from a data science platform because it's all within the database, um, super performant and super convenient. So what you can do is, select a table, right click, auto ML. It'll say, okay, I see this table has this different criteria. I'm going to create a model using, anomaly detection or whatever I think is good for this data. Then you monitor it, you change it with your notebooks, you look at the reports and things like that. Super convenient. So this is really awesome if you're doing, that type of ML on your own data. And again, it's your own data. You're not shipping it around. It's in the database. So that's OML that we're using to detect anomalies with the purchases. And then there's also spatial in the database. This spatial may be my second favorite after transactioning. So spatial, extremely powerful. It is the most powerful spatial database. Um, and all I'm showing here is you can right click on this map and make two purchases and then submit the purchases. And this will do the anomaly detection. Very basic, but just to give you the idea of using anomaly detection and using spatial as part of that, where this purchase was too far away within a time period to not be suspicious and then send an alert. Okay. Um, so just showing off of this, that's very basic as far as all the spatial stuff you can do, but just to give you an idea. Okay, let's move on to the next topic here, which is graph. Now, this is again covering so many topics we can't go crazy into it. But if you ever have time to check out, I think I had it up here. Any of Melly's. Melly is just the master of graph. Any of her presentations. You'll get, a really good deep dive on it. But just to super quickly go through this, Graph is used extensively by many, many financial customers in Oracle, and so it's used for a number of things, such as social networks that we see here, and financial activity. So you can detect unusual money flow patterns, and that's what we show in the app. I'll pop back over to in just a sec. So you can see the financial use cases. Money laundering, of course, is the big one that comes to mind. And it's just, long, long list of financial customers that are using this. So PaySafe, Granty Bank using it in conjunction with, using them in conjunction. In other words, the financial patterns and the social patterns. And then, the thing with graph is you're able to create these associations between tables that would be, 20 join statements, and you may not even detect. You can use that with property graphs if you're familiar with property graphs to have those associations as far as transfer. So you have an account table and you have a transfer table, but you don't have accounts transfers. And that's what the example I use here. We create a graph to show that activity. So that's one thing, the actual modeling of the data, but also it makes it very visual. So you can see, where these anomalies are through the data visualization. Okay. So if we pop back over to here, so all I do here is create random transfers. And Throughout this workshop too, I'm also showing the fact that we're able to use any open source library out there. So this is using an open source for the maps back on spatial. That's OpenStreetMap. This is Cytoscape, like very popular open source libraries for these areas. So all this is doing is creating those, and then this is the graph representation that's powered behind on the back end by Oracle Database. And then with that, we have this Graph Studio, and you can come in here and the main point I want to make here is whatever you're using as far as Python, Java, PGX, the new SQL standard, you can use it all and you can do these notebook operations right on the Oracle database. This is not even, by the way, none of this is a separate process. This is you going into the database and then popping open Graph Studio or popping open OML and things like that. What OML does, just popping back on that topic for a second, it fires up an execution environment for you. So you go in, you have your Jupyter notebook, you do some OML stuff, you do some ML stuff, and then you're done. What it does is it fires up an execution environment, does the work for you, and then fires it back down again. So you can really do a lot of your development, like right in the browser if you wanted to. And it's used providing even the compute for you. So that's pretty convenient and awesome. And so that's what I was just kind of showing here is all the different standards. And these are, if you're coming out of college, I just gave a quick talk on to Georgia Tech a couple months ago, and the timing was perfect because they are using the Graph SQL standard that Oracle was the biggest contributor to. So, anyway, completely adaptable. You get the point. So with that, I'll hand it back over to you, Herman, for the Kafka stuff.
Okay, that was awesome. Thank you, Paul.
Cool, thank you.
Good stuff. So, in this section, we are taking a look at what we call an asset inventory management. Okay, so this is using the Kafka API. So please raise your hands if you know Kafka. I would like to know. Okay, good. All right. So basically, I have good news for those that raise their hands. The Oracle database is compatible with the Kafka API via transactional event queues. Okay, so let's say we have a compatible API, so your skills basically transfer here. In this example, specifically, we show that messaging and database operations can be done in the same local transaction. So what this means is that your messages get the database transaction guarantees, right? So when something happens and you're using a traditional Kafka broker, for example, there's no guarantee that the message is basically following the same transaction pattern as the database. So they are not in the same transaction. So there are a lot of basically checks that you need to do to make sure that you don't run into issues, right? In this case, with transactional event queues, you get the transaction guarantees of the database. So that is really, really good. This is a technology that I really like. Probably I'm right there with you, Paul, in the sense of, transaction stuff, etc. MicroTX is interesting, but transactional event queues is awesome. So let's take a look. For example, here we can select the from account where we want to basically take, and then we have an asset to order, like for example, real estate X, and then an amount, right? Okay, and now we can see here what the code looks like when we use Kafka, plain Kafka, and MongoDB and PostgreSQL. Okay, so you can see the code here, and take a look at the code with our Kafka API via transactional event queues. It's practically the same. Okay, so I have actually seen code that was adapted from traditional Kafka into transactional event queues, and the changes are very, very small. They are minimum, okay? So one of the great things that Paul provided here in this example is what happens if we simulate a crash, for example. What happens, for example, if we have a crash when the inventory in the inventory service after inventory for the order is checked and before the inventory status message is sent. In this case, if you take a look, you see some reds here, right? The behavior using Kafka and PostgreSQL is that you get duplicate message. This duplicate messages. This leads to an incorrect inventory count. Additional coding will be needed, and you must handle locked inventory and ensure consistency. What happens in the case of using transactional event queues? Same API, it's still a Kafka API. You just change the library basically, and the Oracle database. So the inventory modification rolls back, just like in a database, right? Basically, this is happening in the database. So the same behavior as the message received crash scenario. Okay, so this is basically the great thing about transactional event queues. Again, there are like full-blown tutorials and webinars and presentations covering transactional event queues. Just look for that. We just abbreviated to TX event and the letter Q, right? So TX event Q, in case you want to do like a worldwide search. Yeah, so this is basically it. I think that we should move on for the sake of time because we still have more things to cover. But I just wanted to show you one thing before I go to the next. Okay, there you go. So I have this presentation here, Cloud Coaching, Simplify Microservices Architecture, where we are covering in the beginning micro TX, and then in the second half of the presentation, we are covering transactional event queues. And there are multiple advantages to transactional event queues, as you can see here. It's not just about making the message like a transaction aware, but basically, you have pub/sub, point-to-point messages. You have persistent queues, so all these queues are persistent, which is a really great thing. Working with multiple languages, a JMS provider. You can even loop in Kafka here. For example, if you have a Kafka broker, you can make it interoperable with these configurations. So it doesn't mean that you have to basically get rid of Kafka, but you might do a hybrid configuration. So please come back and take a look at this presentation if you can. Okay, so let me go back. Okay, now the next topic that I wanted to cover is true cache. Okay, so this involves the use of this technology called true cache in the stock ticker and buy sell stock scenario, right? So you can see stock ticker right there running, and can you raise your hand if you heard about true cache before, please? Just like make a quick assessment. All right. So for those of you that never heard of true cache, it's a fully functional read-only replica of the primary database that is mostly running diskless, right? So that's why it's a true cache. No disk, but database with database functionality, right? So here we see that we are continuing to use SQL in our application. You can see it right there on the right. So just coming back here, this stock ticker here is basically coming from true cache, which is basically, as I said, a technology that creates a read-only replica of the primary database, and this is diskless. But basically, you talk to it using SQL, right? So it's a database, right? So for example, we can go select a customer here that wants to basically operate on the track stock with buying 120 shares. So track is a 56, I think. So if we use true cash and we do buy, purchase successful, now track change right there, here, okay? And we have a comparison here with true cash on what it would look like if you used Redis, okay? So here in Redis, you would create a client, you would set the stock ticker value, and then you would just set the price, okay, for the stock. And in the case of True Cash, if we go here, let me just get rid of this. We're basically doing the same but using SQL. So for those of you that are very familiar with SQL, actually one of the most popular languages in the world, SQL, believe it or not, you can basically do the same without going into any other type of coding, okay, and getting the advantages of a true cache. All right. So I'm going to leave it here, Paul. Let's move on. Okay, back to you.
Okay, great. I was typing answers, so I will just say them. Um,
Perfect.
yeah. So someone asked, is this, the Swift, apply Swift, and that's exactly right. The Swift bank transfers. The banks do it different ways, but it's always those two atomic operations you need, right? So for Swift, often it's the account update and send a message, or whatever it may be. But that's exactly right. That's what customers use
Perfect.
Tuxedo and for exactly. Um, then the good set of infrastructure. But could you please give us more detail on like the financial domains, such as asset trading and accounting? So hopefully we have, since you asked that question, try to keep it kind of as simple as possible for developers, but show actual financial processes. And as I mentioned, these are the ones we're describing are exactly the financial processes or that different customers are actual Oracle customers are using. So these are, realistic, put it that way. Okay, so the XA stuff. I have to do this super quick. We
Yeah,
saved the
super
XA
quick,
to the end.
please. Yeah.
Yeah. So here's the thing. Agentic AI is what I'm going to show you here using Oracle AI features in the agentic AI space, which is all the hype now. So what I have in the workshop is I'm using Langflow just because it's open source, super popular, okay? And this would be an example here of a kind of a full-fledged wealth advisor or a financial advisor agent. But I'm going to just drill down to, use your favorite tool as usual. I'm just going to drill down to a few key points. And one is using Oracle's MCP server and just how easy it is. So in Langflow, you go in, you come over here, you create an agent, you hook up your LLM, and you hook up any tools, including any MCP servers. And over here, you can configure the MCP server as I have here. If you're using VS Code, there's a plugin to name your database connections. But in any case, that's how you're setting it up. This is, it takes 3 minutes to set up, so I'll leave it at that. And this is, like I say, in the workshop as well. And then you tell the agent, you help the agent out by saying, this is real small, so I'll read it to you. If there are any questions about stock or portfolio, use the MCP server's financial connection and check out these tables. So that just helps it along. And
Nice.
so, yeah, exactly. And then you can just, in this example, you can buy stock. Obviously, it starts to get dangerous and you have the normal disclosures. But we are working, these are some names I can't actually mention as far as external references, but we're working with big investment houses using this exact use case, right? This is very popular financial advisor. So that's MCP. You can do whatever you want to the Oracle database. This is all the rage because it's super powerful and super simple. So there's plenty of material out there for that. This is if you, for using the vector store, the vector database, Oracle database, you could even do this through MCP. Anything I talk about, you can just do through MCP. Say, query this table and do a semantic search on this vector store field. So in Oracle, the implementation is, again, simple. Vector is just a field type. So you have your normal table. Now you have a field that's vector whatever searchable PDF. So in here, I'm showing how you can access the vector database from an agentic flow like in Langflow without using MCP, basically. And so in the repo, you'll see there are a couple components. You just add them, wire them in. You can, feed your PDFs in, but also do the semantic searches. Super simple. And then we also have a AI optimizer toolkit product. Like I said, I won't get into that, but this is like a tool bench for tweaking your models and stuff like that. And you can access that via REST. The one other feature I wanted to mention is called Select AL. So this is natural language to SQL. You give it natural language. There's a few different options here. Super simple. Um, yeah, this will take you 5 minutes to set up. You just say what LLM you want to use. Here's your prompt. And then, do I want to run the SQL? Do I want a narration of the explanation that comes back to me? And I actually have this plugged in to a demo that we do at events where you can ask a question and you can specify the agent that you want to use. Okay. So in case this doesn't work, since it's a live demo, this was my response from the last time where I said, buy a share of Acme stock and use the financial advisor.
Nice.
So let me, yeah, thanks. So let me just try it real quick and see if it works, and then I'll explain what happened on the backside. So,
AI will be making money for us, right? In the
yes,
future.
that's what they say. That's the promise. So if I say, real quick, if I ask a question, describe my stock portfolio using the financial agent. So what it's doing, I can tell it's frozen already. So what it's doing. Yeah, and I don't have my sound on. How did I know? 5 minutes before it worked and now it doesn't. But what's happening is it's taking your using OCI speech, converting the speech to text, sending that text, if you ask to use a specific agent, to that agent. The agent's doing the MCP processing, et cetera, that I mentioned to check your private data using a private LLM, and then combine other information, like Yahoo Finance or whatever it may be. Um, and do vector searches against compliance PDFs and stuff like that. Brings the answer back. Text is converted to speech. Speech is converted to animation, and then that animation is played on this avatar, which unfortunately didn't work. That's definitely a bummer. But you get the idea. When I show this demo, actually, I get more feedback from the financial industry than any, because you want to do these. A lot of financial people want to do these quick. What are my top 5 accounts? Which of them are in Europe? Using spatial stuff like that. So, anyway,
Nice.
yeah. No, thank you. So we're over on time already. I apologize for that, but um, definitely appreciate your time and hope you'll check things out. Let me know if you have any questions.